Hi, welcome back to DevOps course series. This is Satyadev. In the last presentation, I talked about application migration, which is really important uh, when it comes to monolithic architecture or three-tier architecture. Now, in this presentation, I'm going to talk about microservice architecture, how things are better in microservice architecture compared to the monolithic as well as the three-tier architecture. That's what we are going to see. A microservice architecture is a popular approach to designing and building complex software applications. In this architecture, a large application that could be monolithic or three-tier is broken down into collection of small, independent and loosely coupled services. Each of these services focused on specific business capability or functionality and can be developed, deployed and scaled independently. Another salient feature of microservice architecture is that each microservice has its own unique database and it is not shared directly with any other service. Communication with microservice is done using lightweight protocols such as HTTP, HTTPS, gRPC, message queues, etc. With the advent of cloud technologies such as Amazon AWS or Microsoft Azure, Google's cloud, microservice architecture has become a natural choice for application development. Due to its minimal size and independence, a microservice can be containerized easily using technologies like Docker. UI for microservices also can be separated as a different microservice component called micro frontend. So a microservice, basically, just to explain this thing, is it's like a three-tier architecture. However, in three-tier architecture, the entire business logic is there in the application level, whereas in microservice architecture, the entire application layer is divided into multiple services, multiple components. Each component is one feature. Let's say you have a business application, Amazon.com, right? So Amazon.in. You have several operations you perform. Once you log in is one operation, right? After you log in, you select you search, you select, you buy, you pay, you set the address, complete the order. That's what we do. Now, in a three-tier architecture, the front end is in the client tier. All this entire business logic is in the application tier, and the data access is in the data access layer, and the database is going to be there. Whereas in microservice architecture, let's go to the front. We'll go to the front end and the data access little later. The actual business logic, which is very, very important, itself is split into multiple. That means login one component, searching one component. Let's say separate application. Component means a separate application. Search is one component. Selection is one component. Pricing is one component. Cart, payment is another component. Like that, everything is separate components. So they are all like individual small chunks of things. They will be running independently. Similarly, front end. You have a small front end for the login. Similarly, like that, you have everything like small pieces. Similarly, data access line. For login, how to connect database? So login database is one table, only one login table, and it's not shared with anybody. Yeah, the data will be shared, but not directly. Nobody directly writes to the table or read from the directly. So there are certain challenges which I will discuss in another presentation series, not in this presentation series, because this presentation it's not really required to go in depth into microservices. So I won't talk about the challenges of database, which I will discuss later in later presentation series. So yeah, so this is how the microservice architecture is organized, and the communication is through lightweight protocols. Hey, there it could be like heavy protocols like TCP, IP, or anything like that, right? Or SOAP or anything like web sockets or something like that. Whereas here you use only REST, basically REST and HTTP or REST. Those kind of technologies we could use. We'll talk about those technologies. When UI is componentized like small pieces, it's called a micro front end. If it is a business logic, it is, or a data access, it's called the microservices, right? So this is how microservice architecture is designed. Now, what are the characteristics of microservice architecture? Small and focused, organized around business capabilities, which I already talked. Each microservice implements a single business capability. Example, in e-commerce application, product catalog, I just talked about shopping cart, order processing, user management, payment, etc., are all can be implemented as separate microservices. Whereas in a three-tier architecture, all of them is into one business layer. Their UI is client layer. Their data access is data access layer. Three big pieces. Even though they are separate, but three big pieces. In microservices, you again further granularly, vertically cut them down. Independent deployment, obvious, right? Services can be deployed, tested, and deployed independently, each other, independent of each other, right? This means a service can be updated without having a redeploy of the entire. This is the big advantage, right? So let's say you have a bug in order processing, you just fix the order processing application and you just deploy that. You don't want to touch the shopping cart or product log, catalog, or user management. Whereas in three-tier, yes. Whereas if you, the advantage of three-tier is front end, you make a change, you don't have to worry about it in application layer and the data access layer. But if you make some change in the application layer, the entire application layer has to be tested, right? Whereas in microservices, if order processing is changed, just order processing needs to be tested and deployed. It doesn't need to. You don't need to deploy all the things, right? That's the advantage. Loose coupling, obvious. Services communicate with each other through well-defined, lightweight APIs using protocols like HTTP over REST, asynchronous messaging like Kafka, or messaging, RabbitMQ, etc., etc. Decentralized data management. Each microservice typically owns its own data store. This is a crucial feature. In monolithic as well as three-tier architecture, we have only one database. All of them, it's being shared, right? Whereas in microservices, each service has its own database. Like for example, in the shopping cart example, product catalog got its own database. Shopping cart, its own database. Order processing, its own database. Like that, everybody has got its own database. Again, that database is not huge, maybe one or two tables and some stored procedures, nothing more than that. But you are separating them out, like it's separation of concerns, right? Really good. But there are challenges which we will discuss later in the presentation. That is what is December. Each microservice typically wants its own data store optimized for a specific need. This means one service might use RDBMS, another use NoSQL, all within the same large application. So you have a lot of choice. You use SQL Server for one application, Oracle for something, or NoSQL for something else. You just use a file for another thing. You do whatever you want to do. You don't need to follow one database for everything. That kind of thing you don't do. That's the decentralized data management. Polyglot persistence and programming. Teams can choose their best technology stack. Same with the client server, but here also more granular, right? For each component you can choose your own technology. So programming language, framework, database, for each server, and rather than being restricted to a single organization-wide choice. So you have a lot of choices based on the need and the what fits best for this thing. You can use the technology like that. Again, this is very, very important in the perspective of DevOps and Agile. Owned by small autonomous teams, small cross-functional teams, often called two pizza teams. What is two pizza team? Is like you buy two pizzas, that's enough for the entire team. Like that. So that means like 5 slices or 6 slices. That means enough for the small enough for the entire. That means it should not be a big team. Take full ownership of one or more autonomous microservices from development to operations. So that means a team handles maybe product catalog and shopping cart. Another team handles only order processing. Another team handles user management and payment. It depends upon the complexity of the component. Either one business capability or so. They are small teams, take up small things, but they are focused on those small things, right? That's what it is. Cross functionality. This again, they interact with each other. Everybody talks to DevOps. So there's a lot of communication going on, right? So it promotes the DevOps culture. That's what this microservice architecture is. Let's see how this microservice architecture works. Now you see app. This is a client app, browser or app. You have mostly it is browser, but you can have operating system. You can start. You can do that, but mostly it's a browser. Now you have a API gateway. You don't have that in three-tier architecture. You have. I'll talk about that little later. Then you have load balancer 1, 2, 3. Now you see the load balancer. This is for the micro front end, and this is for the one instance of the service. This is for the another another business functionality. This is one business functionality. This is second business function, right? And you see there is database A, database B. For this, there is database A. So let's say there is business functionality A. This is functionality 2. They are load balanced. B, load balance. Now, what is API gateway? This is very important, right? So now you see all of them are different, and see doesn't use any database, right? All of them are separate. They expose their own thing. Normally, not normally. I think the architecture of microservices is that they expose through APIs. That's what I told you in the previous slide, right? So all of them are exposed through APIs. Now this load balancer exposes some API, like API 1, 2, 3. Here API 4, 5, 6, like 4, 5, and 6, 7, 8, 9. Of course, this is not API, but yeah, could be API, like show form kind of thing, right? So 3 methods. API basically means method names, right? Now, for a client, see Amazon, you see Amazon.in, right? So in that application, everything like a single thing. Actually, they are not. So they are from different aspects. That's the reason sometimes one component loads faster than another component, because they are, when it comes to UI, right? When you have a very slow machine or slow internet connection, you would see that. When you open Amazon.in in a slower machine with slow internet, you see some component pops up first, some component pops up little later, because they are all separate things. But for user, once everything is loaded, it looks like a single application. So they are all different. But you need to have a single kind of thing, right? Single way. The gateway, API gateway, is to combine all of them and show it to the outside world as one thing. That's what API gateway. So even though there are all different APIs for each one of the components, API gateway combine. It does a lot of other things which outside the discussion, but it combines all of them and stores shows it to the client, right? So the browser will show everything. This is how. Now, like again, vertical scaling, horizontal scaling is there. This is front end, and and also you see that there is no common database, right? So there is one database for each service, right? This is the architecture of the microservices. So yeah, let's see the pros and cons. Mostly cons are there are few cons, but they're not strong enough when you compare to pro. But there are certain things which you have to focus. Let's go through them. Now, scalability, fine-grained independent scaling, complex orchestration, increased network latency. Obvious, right? So multiple. You see that there are so many. You are just talking about two services. Let's take up a service like Amazon.in. There could be a lot of components there, right? So you have to scaling, orchestrating. Orchestrating means managing, basically. It takes a lot of time. That's why the first one complexity increases, but it provides the flexibility, and that's what it is scaling. So you don't want to you want only one instance of the service, but 10 instances of the service. Fine, you can do that, right? So it's possible. It's flexible, but a bit complex. Deployment, faster independent deployment. Again, CI/CD, a lot of CI/CD components have to be set up, complex CI/CD. But again, the CI/CD is only one-time setup, right? Once you set it up, once it is working, you don't need to touch it for a long time, right? So maintenance, easier in isolation, harder to trace across boundaries. This is the one that needs some attention. Let's say somebody is using this calling front end and this service and this service. Now somewhere there is a problem in this service and it's down or it's not giving expected results. Now because this communication is not like direct communication, loosely coupled communication through web methods or REST APIs, it is difficult. You have to trace from here to here to here to here to here, right? So you need to figure out things, in a harder way. So tracing is difficult, of identifying where exactly the problem, because you have to cut across multiple things which are all independent. So that is what it is talking about in the maintenance. Development speed, parallel team delivery, which you talked, requires cross-team coordination, more cross-team coordination, which is actually good, which is bit more talking time, but which is good because liaison between among operations team and development team is going to be more. Flexibility, polyglot and modular, we talked about it. You can use any technology, any language. When you want to see it as a merit demerit, you can see it like you use Angular in front end, and one component use Java, another use C#, another use Python, another service use Python. You could have that. I mean, there's nobody stopping you because they're all communicate through REST API, right? So you could use them. Like multiple technologies are there. So, I mean, it's a complex thing. So that's what it talks about. Resilience and fault tolerance, like even one thing is done, you can up it up quickly. Robust distributed requires a robust distributed system error handling, same as the first one. Organizational structure, autonomous teams, communication and coordination. Yeah, I mean, teams are autonomous, but they need to communicate with each other. So there could be some clashes sometimes, which needs leadership, intervention, and stop it. Make sure that everybody is on the same page. Certain challenges are there when it comes to communication, but teams are independent, autonomous. Data management, decentralized data management, no complex issues, big migration issues which we discussed in the previous presentation, no issues like that. But you want to share data from multiple databases, which we could do, but not directly through indirectly. That's becoming more complex. That's what it is talking about. Data consistency challenges. So yeah, I mean, there are going to be certain challenges which I will talk, which I may not talk in this presentation series, but yeah, maybe another one. Testing, easier unit integration testing, complex end-to-end testing. These are pros and cons. Integration testing, unit testing is easier, integration testing easier, whereas end-to-end testing you want to do because they're all different components, not communicating directly with each other. Debugging challenges are going to be there. Security, granular security controls, that's a pro. Increased attacks due to more network endpoints, obvious, right? So you have more instances of more services, so more endpoints, more issues. Infrastructure cost, lower cost, long term, higher cost in the beginning. So obvious, right? So that's what it is, pros and cons. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.